In this video, we shall look at a couple of rules of integration. We shall look at integration of functions like x to the power n or any combination of them, and trigonometric functions such as cosine a constant x, sine constant x, and so on. An integral can be written in the following manner: fx dx. Fx is called the integrand, and dx is called the differential of the variable of integration. So in this case, the variable of integration is x. This integral does not have any limits. Integrals with limits are usually written like that. So this a is the lower limit, b is the upper limit. If you do not have these limits, like this integral is known as the indefinite integral. The process of doing this integral is called integration. It's important to realize that integration is the reverse of differentiation. What that means is, assume that this integral equals a function gx. Then, if you differentiate gx with respect to x, the answer is fx. We shall look at two classes of functions and see how to integrate them. The first class is x to the power n, where n is a constant. The result of this integral is x to the power n plus 1 over n plus 1. And we usually add a constant to the result. Now we can see that if we differentiate the right-hand side, you get n plus 1, x, the power will get reduced by 1, and over n plus 1. And then when you differentiate a constant, you simply get 0. And the answer is just x to the power n, which is the integrand. So here you see how integration is just the reverse process of differentiation. Another class of function that we are interested in this video is the trigonometric function. So assume that you want to integrate this function. Since in differentiation we learned that when you differentiate, say, sine function, you get cosine function. So when you integrate cosine, you should get sine. So our guess would be sine ax plus b plus a constant. In this case, the argument is a little bit more complicated than just x. You have ax plus b, where a and b are constants. So when you differentiate ax plus b, you simply get a, and that a should be written at the bottom like that. And this is the complete result of integrating this function with respect to x. Likewise, if we have to integrate a sine function, we remember from differentiation that when you take the derivative of, say, cosine x with respect to x, you get minus sine x. So this minus sign plays an important role here. So in this case, we can guess the answer will be minus cosine ax plus b plus a constant. And however, as before, the argument of sine is ax plus b, where a and b are constants instead of just plain x. So when you take the derivative of ax plus b with respect to x, you get simply a, and that a appears below. And this is the entire result of the integration. Now, two important rules. If you have an integral like that, a fx dx, a is a constant, then the constant a can be taken out of that integral sign and be written like this. So this is rule number 1. Rule number 2 is that if you have a bunch of functions involving sum or difference, let's say function u plus v minus w, and all these u, v, w are functions of x, then this integral can be broken into three. So the first one is u dx plus v dx minus w dx. While these rules seem simple, they play important roles in doing more complex integration, so it's worth noting them. Let's do the following example. The integrand is 1 over square root x. Now, 1 over square root x is just x to the power minus half. So what you're integrating is x to the power minus half with respect to x. And according to the rule that we have discussed, it will be x, the power will be raised by 1, so minus half plus 1 over that power is written in the denominator, plus a constant c. So the answer is x power half over half, which is just 2 square root x, and don't forget to add c. And that's the full result. Likewise, in this integral, you do the same thing. The power of x in this case is minus 1 over 4 will be raised by 1, and the result of that is also written in the denominator, plus a constant. So you get x to the power 3 over 4 over 3 over 4 plus c, which is 4 over 3 x to the power 3 over 4 plus c. And that's the answer. Let's look at the following problem. The power is 1.4, so raise the power by 1 and divide the result by the power. 1 plus 1.4, and don't forget a constant, so the answer is x to the power 2.4 over 2.4 plus a constant. Let's do this integral. A is a constant, so you can take that a out of the integral sign, leaving you with that. And if you rewrite it, it is just x to the power minus n, and it's also a constant, dx, and it will give you 1 over a, raise the power of x by 1, you get that, and divide this result by that power, and plus a constant. So you get 1 over a, 1 minus n, x to the power 1 minus n plus the constant. Or you can simply write it as 1 over a, 1 minus n, bring the x down, so it becomes x to the power n minus 1 plus the constant, and that's the answer. In this integral, it's important that we expand the bracket. So the first term is x squared, the cross term is just 2, and the last term is 1 over x squared dx. So let's do one by one. The first integral is easy. It's just x to the power 3 over 3. You raise the power by 1 and divide that result. Minus the second one is 2. So 2, when you integrate dx, you're integrating 1 dx. 1 is just x to the power 0 dx. So raise the power by 1, you get x to the power 1, and you divide that by 1, which we can simply write like that. And the last term is x to the power minus 2. So if you increase the power by 1, you get minus 1 over minus 1, and don't forget the constant. And one could rewrite this as x to the power 3 over 3 minus 2x minus 1 over x plus a constant. So this is the result. Now let's do this integral. Again, you have two integrals. So the first one is 1 dx, so that's the first integral. The second integral is x to the power 2 over 3 dx, because an integral term that's written like that is just x to the power 2 over 3. And as before, integrating 1 will just give you x. Integrating x to the power 2 over 3 will give you 2 over 3 plus 1 over 2 over 3 plus 1 plus the constant, which can then be simplified as x plus 3 over 5 x to the power 5 over 3 plus constant, and that's the answer. Let's do problem 7. First, we need to use trigonometric identity to expand that, and that's going to give you sine 1 minus x is just sine 1 cosine x minus cosine 1 sine x. So this integral here can be broken up into two. The first integral is sine 1, which is a constant, cosine x dx minus cosine 1, which is again a constant, sine x dx. Now we can take the constant out, so sine 1 outside. Integrating cosine will give you just sine x, as we have discussed before. Minus, take the cosine 1 out because it's just a constant. Integrating sine, you get minus cosine x, as we have discussed before. And don't forget that overall constant. So you get sine 1 sine x plus cosine 1 cosine x plus the constant, which, using the trigonometry identity, these terms will simply become cosine 1 minus x plus the overall constant, and that's the answer. Let's do a similar type of integral in a slightly different way. At the beginning of this video, we say when you integrate a cosine, you get sine. So let's write down that full sine. Sine 1 plus 3x. In the original integrand, you have 1 plus 3x. So when you differentiate that with respect to x, you get 3. So write that 3 below, plus a constant, and that's your answer. What about this integral? One particular identity in trigonometry is sine 2 theta is 2 cosine theta sine theta. So if we use this identity in this integrand, you see that the integral above can be rewritten in the following manner. So 1 over 2 sine 2 times 2x is 4x dx. Keep in mind half is a constant, so you can take that out. Sine 4x dx. And we know that integrating sine will give you a minus cosine 4x. Now when you take the derivative of 4x with respect to x, you get 4. So you divide the result by that 4. And don't forget the overall constant. So your final result can be written as minus 1 over 8 cosine 4x plus constant. And that's the answer. If you have found this video useful, please click subscribe, like, and share for notifications on more videos. Thanks for watching.